Good evening, everyone, and welcome to the Berkeley Forum. My name is Charlie, and I'm the president of the Berkeley Forum. We are a nonpartisan student organization that hosts free debates, panels, and talks on the UC Berkeley campus. Thank you all so much for coming out tonight for our really interesting event on bias in machine learning. My colleague Noah will be introducing the speakers in a second, but before we get started, we'd like to hear a word from a representative from Blockchain Berkeley, Mr. Ayush Agarwal. They are co-sponsoring with us.
Thanks. So my name is Ayush. I'm part of Blockchain at Berkeley. We're just helping cover some of the costs for this event. I know on the surface, blockchain and machine learning don't have much interrelationship between just both being buzzwords. But on the data science, or rather data management part of machine learning, blockchain and distributed systems can play a very important role, both in increasing the data integrity of the data we feed into our machine learning models, and in the governance layer of the actual people decisions being made in these algorithms. So I'll tell you a little bit about our club. We have a research department, education, and consulting department. We work with Fortune 500s, blockchain startups. We teach 2 decals on campus, and we have open source education online for over 130,000 users at this point. We're always working on cool projects. If you're interested in system design, blockchain, cryptography, anything related in our whole blockchain tech stack, definitely find me, talk to me, and feel free to hit me up on any social media.
Thank you. All right, and now I'd like to invite our student moderator for the evening, Noah Oppenheimer, up to the stage to introduce the speakers.
So, hello everyone, and once again, thank you for attending tonight's session of the Berkeley Forum, a panel on bias in machine learning. The format of this event will be as follows. I will first introduce each of our speakers, after which I'll ask them to make a quick 3-minute introduction, introducing themselves and their opinions on the matter. After that, we will move into the moderated Q&A portion of the event. That being said, I'm excited to introduce our first speaker, Mr. Kyle Dent. Kyle Dent is an AI researcher interested in the intersection of people and technology. He manages the Machine Learning and Data Science Group and co-chairs the Ethics Review Committee at the Palo Alto Research Center for Park. The committee conducts project reviews to consider potential ethical consequences from Park's work. The committee also helps Park researchers to understand their work within the larger context of society and the impact that work has on individuals and social systems. Yeah.
Okay. My 3 minutes. Right, so I just want to say a little bit more about the AI Ethics Committee. It's actually a grassroots effort that was started by researchers within Park, myself included, but we were kind of seeing what was happening in the world as more and more AI was being deployed and harm was being done because of the AI. So we looked at our own work and thought, like, can we mitigate the harms that we were putting out in the world? What can we do to lessen that with our own work? And so the committee was formed to do that, and we now have a process for reviewing projects as they're getting started, but also educating the wider population at Park. As far as AI ethics and bias and machine learning, I like to emphasize 2 main points. One is that bias can enter into machine learning through things other than just data. I'm sure we'll talk a lot about bias in data, and that's very important, but there are many other ways that bias can get into machine learning. Researchers or AI engineers are choosing data sets to begin with, and they're not thinking about, they may not be thinking about if these data sets that they're working with are actually representative. They're choosing weighting schemes. They're selecting algorithms. All of these things can have real-world effects when their technology is deployed. But at the point they're making those decisions, they're not thinking about it in those terms. So I think it's the very important element is to think about how, even apart from the data, technology is not neutral. The second point I like to make is that we're deploying technology probably beyond its capabilities. That we as a society are not looking at how accurate is this actually, and what effect does that have on the people that it's being used to make decisions about. So vendors are selling solutions, often proprietary solutions that the public is not allowed to see. So we have no chance even to analyze those solutions to make the decisions about whether this is a good choice or not. And I'll stop there and go on to the next.
Thank you for your presentation. And with that, our next speaker will be Catherine Luna. Catherine Luna is a senior machine learning scientist at Apple, working in search auto-completions and ranking. Prior to Apple, she worked as an algorithm specialist at a smaller company called Guardian Analytics, an industry leader in preventing banking fraud by using behavioral analytics and machine learning. She holds a PhD in physics and an MS in financial mathematics from Stanford University.
Thanks for that introduction. So right now I'm at Apple in search auto completions and rankings. So if you use, say, an iPhone, Safari, Spotlight, all that stuff, you might have seen my work where you type in FAC and you see Facebook or Facebook stock and how you do the ranking associated with that. There's a lot of issues involved with bias there, from anything of, say, if you're translating from one language to another using, say, neural machine translation, oftentimes it assumes a certain gender, say like male, for example, and so you superimpose something incorrectly when you're doing translations. There's other things involved, even say like image search. So if you Google like wedding, for example, what is the probability that you'll see a white female and a male together? Rather than having more balanced of our population, or rather than heterosexual marriage, it can be non. So all those things are involved in terms of search. So hopefully we might discuss some of that.
All right, thanks. Thank you, Ms. Luna. With that, our next speaker tonight will be XIA. X is a global outreach lead at Google for responsible innovation, preventing unfair bias in Google AI products. She has years of experience in the software industry as both an engineer and account manager. She was deployed to Afghanistan from 2012 to 2013 as a founding member of a military unit focused on data-driven operational planning.
Thank you for the introduction. Hello everyone, my name is X, yes, just the letter. At Google, I lead outreach for a team called Responsible Innovation, which created Google's AI principles. The AI principles, there are 7 commitments, so basically how we will build machine learning, and what we call 4 red lines, which are 4 clear commitments of how we will never use machine learning. In my role, I work with every single product area at Google, so every single Google product, whether that's Gmail, YouTube, Search, Play, Android, all of our hardware devices like Nest, Waymo, all of those wonderful companies that come out of Alphabet as well. And we build operational processes to figure out, hey, we've got these great principles, they look good on a blog post, but how do we turn them from a marketing campaign into an actual review process? How do we check every single one of our products for alignment with these principles, which include things like being socially beneficial, avoiding creating and reinforcing unfair bias, ensuring that they're held to the highest standards of security and privacy, and also making sure that anything we produce, whether that's a product, a research paper, or something as simple as a blog post, doesn't end up being abused by somebody on the other end, so that it doesn't end up coming as a violation of our product. Simultaneously, we also work with Google Cloud to ensure that every single cloud deal that we sell is also in alignment with these principles. So we won't sell Google Cloud to someone who's, say, planning to do something that could potentially end up in unfair bias. Two key points, I know we'll talk about that a little bit more later, because you guys are probably like, how do you do that? 2 key points that I want to make is that, 1, fairness is not universal. So at Google, we tend to take an approach, because we are software developers sitting in North America, that fairness looks like what we feel like fairness looks like in our societal context. So if you do some research after this, you can look up something called Jigsaw. They have something called the Perspectives API, which was a toxicity classifier that looked at taking in a string of text, like let's say a comment on a YouTube video, and it would assign it a toxicity score to say, hey, this is likely to be something bad, it's likely to be something good. And some of the challenges with that is that it ended up overrepresenting LGBTQ identifiers as being negative. So you could say, I'm a gay black woman, and it would classify that as 80% toxic. And then you could say, I am a straight male, and it would be like 0.20% toxic, right? And so when we go into the American context, that's horrible. But when you go into certain parts of the Middle East, certain parts of Eastern Europe, certain parts of Africa, where let's say being LGBTQ is illegal, how does that system then translate to being fair in those contexts, where societal, regional, and cultural differences don't necessarily align with us who are building those systems? So one of the most complex things that we have is not just on a technical level, is the system performing for different users, but how does it perform in different societal contexts? How do we end up making sure that these applications work well without forcing moral obligations or moral beliefs onto different societal contexts? The second thing that I want to really drive home is the point that Kyle made earlier, which is that bias is not just in data. That's kind of the entry point, and the net is definitely one way. Another way that it can enter in is in the way that the machine learns patterns, and also in the way that it's perceived that the system's being used. So how many of you just can't wait for the United States government to adopt facial recognition? Yeah, I thought so, right? So even if that system was 100% technically accurate, meaning that it could identify identical twins and tell them apart, most of us wouldn't perceive that use case as being fair in the United States. So fairness is not only about how the system is technically constructed, it's also how we perceive the system, how we perceive its use. So I'm very excited today to get to share some of the lessons that I've learned working with Google's products, which reach billions of people, and look forward to hearing from our other panelists.
Thank you so much. And last but not least, our final speaker tonight will be Sherrod Goyle. Now, Sherrod is an assistant professor at Stanford University in the Department of Management Science and Engineering, and also holds courtesy appointments in computer science, sociology, and the law school. He's the founder and director of the Stanford Computational Policy Lab, a group that develops technology to tackle pressing issues in criminal justice, education, voting rights, and beyond. In his research, Sherrod looks at public policy through the lens of computer science, bringing a new computational perspective to a diverse range of contemporary social issues, such as policing practices, electoral integrity, online privacy, and media bias. Before joining the Stanford faculty, Sherrod was a PhD in applied mathematics at Cornell University and worked as a senior researcher at Microsoft.
Thanks for the introduction, and thanks for all of you for coming here. So I just want to emphasize again this point that X made, that a lot of what we talk about algorithmic bias or algorithmic fairness, part of this is an algorithmic question, but I think a lot of it is how we use these technologies. In my mind, that's the hardest part of all these decisions. That it's sort of funny, even this language of fair ML or algorithmic bias, it tends to forefront the computational aspects of it, but I really think we need to think about the policy aspects of that. So I'll give you two quick examples. So one algorithm that we recently deployed in San Francisco in the district attorney's office is to mask race and race-related information from police narratives as they enter the office. And now most new felony cases are going through the system. When attorneys are reviewing these cases, they do so without seeing this race-related information. Now, the question though is, what should be masked? And we can mask pretty much anything, but it's a hard policy question about what is it that you should design the system to do. And that's something that really came out of not technical conversations, but policy conversations with people in the office to understand what is really relevant for making those types of decisions and what is not, and what can we blind the prosecutors to. The second example is in risk assessments, and criminal risk assessments that I'm guessing many of you in this room have heard about. So these risk assessments are used all across the country, including in California, including in San Francisco. And at a very high level, what they're doing is trying to predict the likelihood that an individual who has an upcoming court date will miss that court date or will be arrested for some new offense within the next couple of years. Now, that information, in some sense, is just there. It's like it could be a statistically accurate, best case is a statistically accurate representation of that individual. But what you do with that information can be problematic or supportive. On one end, you can say this person is a high risk of failing to appear at their next court date, and you can decide to incarcerate that individual, which in many jurisdictions is a default. Or you can say this person is high risk of missing a court date, so we're going to try to figure out why and then provide services to them. So for example, we might get them door-to-door rideshare service to get them to court. So that's one of the things that we're actually starting to roll out around the country now. And so here it's the exact same algorithm, but the policy decision that you make at the end of the day is what I think really colors the way that we think about whether or not that use was fair.
Thank you so much for your time. Thank you so much, once again, all of you, for your presentations. And we will now be moving in to the moderated question and answer portion of our event tonight. Now, one thing that kind of repeatedly came up throughout those presentations is the idea that it can be hard to tell exactly what is fairness in the context of machine learning. And so I think to start by clarifying kind of what we're talking about here tonight, it'd be good to ask, in your eyes, what specifically does it mean to make machine learning models bias-free or fair? And I'll start with Mr. Cohen.
Thanks. So I think it doesn't actually make a lot of sense, in the sense that we wouldn't really ask a piece of legislation. It's like, how do we make this legislation fair? We say, oh, that's a pretty complicated question. There's not going to be some algorithm, some meta algorithm that we stick this complex piece of legislation through, and then out comes like a green, this is good, or red, this is bad. But somehow we expect something similar to happen with algorithms. And so I don't think there's a simple binary, this is fair or not fair. I really think about the consequences, the impacts of rolling out various types of tools. And again, it's not even the tool in isolation, it's what your menu of options are. And so even if I have something which I don't think is perfect, maybe the alternative is even worse. And so in that sense, this still might be fairer. But even though I say in some sense I work in this area of fair machine learning, I actually don't think that phrase itself is nearly as meaningful as we often consider.
So at Google, we have a very specific definition of unfair bias, which is tied to US protected classes, right? So meaning like we don't want to create new bias for like people based on what we call group membership. So like race, gender, identity, ability status, nationality, refugee status, immigrant status. But I think beyond that, ultimately what that's trying to get at, because again, we took that definition to other cultural contexts and we're like, ooh, we might need to tweak this. It doesn't necessarily land in different contexts. And part of what we look at is, what is the impact of this algorithm? And is this algorithm unfairly or unjustly impacting one group of people over another? And what that means in different cultural contexts looks different. So for example, the impact of me, let's say, recommending you the wrong book to buy is a lot different than the impact of me recommending that you be arrested for you potentially not showing up to court. Those have very different impacts. And so what's interesting is the EU actually, just recently, I think last week on the 19th, released a white paper on how they believe that they should define fairness in AI. And I kind of like this approach, which is they pick out certain sectors that they consider high risk based on the impact. So like, the impact of me recommending the wrong cancer treatment to you is very different than me recommending appointment times that you might not be available for. And so I think part of when we look at fairness, what we need to be looking at is not just what the technical measures are, right? Because if you look at something like accuracy, well, is it accurate for all those groups? Well, if it's 99% accurate, but that 1% accuracy is 5 million people, or 10 million people, or people from a vulnerable population, or from one particular membership group, then is that fair? So there is no like mathematical definition of fairness, although there are many ways to slice and look at what fairness can be through mathematics. So you have something called accuracy, you have something else called precision, you have recall, you have false positive rates, false negative rates, true positive rates, true negative rates, and these are all different mathematical formulas to help you understand on a technical level whether or not your algorithm is performing pretty commensurate across different groups. But I think the biggest thing to think about is, what is the impact of this algorithm? What is it going to be when users actually end up using it? Does it have the potential to harm them? And that's kind of the approach that we take at Google when we sort of review our own products, right? So one really interesting example of that is a research paper that came out. And the research paper was on using computer vision systems to read people's lips. So to be able to basically do lip reading into translation. And one of the major concerns was like, hey, whoa, whoa, whoa. What if like the government uses this and then they start like reading my conversations through CCTV cameras, right? And so we did this whole analysis of this research paper to see, would that even be possible? Because the harm of that, even though the benefit of that paper could be that maybe we make it easier for folks who are vision impaired to be able to access conversations with folks who are hearing impaired if we translated it over to text, to be able to understand what people are saying, right? The harms could be very big. So when we did a research on it, when we did sort of an analysis on it, what we ended up finding is that one, CCTVs like are always low-grade cameras. You can't actually like read people's faces on a mass scale. And two, that the computer vision system wouldn't be able to process mass amounts of lip reading at once. And we made sure to limit the research in that way to make sure that when people use that research, they could then go off and build a system that would allow mass surveillance. So it's kind of like the benefits outweighed the harm, right? Because the reality of somebody building some mass lip reading surveillance system was very, very small in comparison to the benefits that these technologies could have for folks of different ability levels. So I think you have to kind of weigh everything as it comes in. There's no universal definition of fairness, and the definitions of fairness we have here in the US don't scale across social, cultural, and geographic boundaries.
So I guess as kind of the engineer kind of building the product in terms of bias, I feel like at Apple it's a bit smaller, that we don't have necessarily like a fairness team that oversees us. So it's really up to us to decide what makes sense. And it's actually at the end of the day up to maybe 3 people to decide whether we deploy our model or not. So one example would be corrections, right? In Spanish, for example, there's oftentimes things with an A or an O would determine if it's male or female. But if we do something at a global scale, right, for corrections, does it improve engagement rate overall? And even, you know, if we're making mistakes, if the engagement rate goes up, is that good enough? You know, that's better than what we've been showing to the user now. So then it's really up to, you know, maybe 3 people in the room, the manager, the product manager, and maybe a more senior person to determine, should we roll this out, even though it's not really great that there are some errors involved. So definitely areas that could be improved in terms of improving bias in machine learning rather than it just being up to the engineers themselves, because engineers themselves, sometimes they care, sometimes they don't care. And it's really up to the person's personal ethics, whether they want to roll it out or not.
So I think there is no singular notion of what fair is. And it doesn't just differ along cultural boundaries. People in this room will disagree about what's fair. And all of our public systems and our economic systems are arranged for us to work out what is fair. We're constantly having a discussion about what is fair on a multitude of topics. And it's very dangerous to think that we can build algorithms or machine learning models that are fair, because that shuts the conversation off. These are ongoing conversations, and our ideas about fairness can change over time. And if we build models that we deem to be fair, then those models have now become the embodiment of some notion of what is fair, and they're basically encrusted into this technology. And that becomes what's used, whether it's fair or not, whether other people disagree, whether notions of fairness change over time. I think the whole idea of fairness in algorithms is a dangerous one.
Thank you so much. So I want to go back to something that Ms. Runa brought up, which is the idea of working toward a specific goal, like engagement rate or something like that. Now, machine learning models are often designed with a specific goal in mind, say maximizing revenue, click-through rate, or engagement. But how, if at all, could incentives be reformed to really incentivize engineers to create models that also ensure fairness?
Yeah, that's a good point, because oftentimes the engineers are judged on models that they release to production, and that includes increasing the engagement rate or coverage of, you know, what the user clicks. There is no sort of judgment of like, oh, I'm improving fairness at all, even if the engagement rate is going down as a result. So really, I think it would have to come from you know, someone higher up that says this is something that we believe in and want to strive towards, and you know, that if you implement it, you'll also be judged in a positive way, rather than just kind of churning out models of increasing this engagement rate or coverage.
Maybe take a quick on this.
You can all go ahead and answer.
Yeah.
So I think that's a good point. I would maybe expand it and say that it's not even engineers, and it's not even necessarily someone higher up in a company. I think these are pretty big social issues, and you know, I do think there's some room for kind of internal decision making on these metrics, but I think we do have to acknowledge that incentives are not fully aligned. And so what happens inside of companies that are designed to maximize profit are going to be not necessarily in line with broader social objectives. So this is tricky. It's a tricky conversation, and again, I don't want to minimize the role of internal regulation, but I do think this is kind of a fundamentally tricky challenge when you're saying engineers make something that is fair, whatever that means, but at the same time make sure that we're making a lot of money.
So as a global company who is dealing with this every single day, at Google what we learned is we had to fundamentally shift our incentive structure. Anyone who's done a software development internship or just studied software development, you're familiar with the agile approach, which is every 6 to 8 weeks or however long your sprint is, you're supposed to be cranking something out, right? And that speed can be counterintuitive to building things that are fair because you might overlook something, you might not have time to do testing, right, in a way that's comprehensive that allows for these types of reviews. So kind of what we've adopted now is a slow down to speed up approach, which means slowing down, being more mindful, making sure that we have the right voices at the table, whether they be internal voices by tapping into our employee resource groups, whether it be external voices through partnerships with groups who specialize in this, groups like Joy Bolawamini's Algorithmic Justice League, Data for Black Lives, international groups who work on this type of stuff, to make sure that as we're building these products that have these types of implications, that we're building them with enough mindfulness so that we're not just moving quickly to like be first to market on something, but that we're first to market in service of our own values as a company, which is to ensure that we make the world's information universally accessible. So if our products don't work for one user, then we're fundamentally failing at our mission. So again, we've had to take sort of a slow down to speed up approach and fundamentally change some of the incentive structures around how we reward engineers, where it's not just about how quickly you land things, how quickly you launch products, but around the quality of those products. And that's been a very, very difficult process and is still ongoing. So even as a global company with 100,000 employees, this is something we're still figuring out, and I don't think that there's a single answer for it.
I think the reality is that most engineers are not paying attention to this, with the exception of X, whose very job is this. You come up with some idea of a metric for accuracy, whatever that is. So accuracy is a broad term. There's probably something more precise that they're working towards. But whatever that metric is, they zero in on that, and then maximizing that level of accuracy becomes the most important thing. And there's usually no consideration of what the actual impact on the world will be. It's my model is accurate. It's performing against this metric I've chosen, and it does a really good job of that.
So to look at kind of the implications more specifically and dig in a little deeper here, a study published in the Journal of the American Medical Association found that clinical decision-making algorithms are often trained on data that lack representation of individuals from a lower socioeconomic status. So what, if any, are the larger implications of excluding arguably disadvantaged groups from, or disadvantaged populations from the training data that's used in such algorithms?
Yeah, this is a huge problem, and it's not a machine learning problem. We've seen attitudes in emergency rooms, depending on race, can change, and it's a bad situation. I think at least in clinical settings, they have a culture of reflecting on what they're doing, and they're starting to realize that this is wrong. The risk is, again, that we bring in technology and we train it on the history that we know is bad. So it comes to embody that and reflects that history. It's clearly, this is something we have to step back and take a look at. And it's not just in the technology, as Sherrod pointed out, these are policy questions that are, it's tied up because we're making technology decisions, but the policy questions are paramount.
So I think there was another study that came out recently that showed that a healthcare decision-making algorithm was basing its treatment decisions on prior spend. So this was, thank goodness, not a Google product. But this research paper showed that because it was basing it on prior spend and not accounting for like the societal and cultural nuances, meaning different people from different backgrounds have different types of health insurance, they have different cultural beliefs around going to a doctor, the algorithm actually was treating healthy white people over sick African American people, right? And it was doing this for 30 million people across the country. Because that data didn't represent the patterns and the usage and the mentality around the way different groups actually leverage healthcare. So an example of this completely absent of machine learning would be crash test dummies. So it wasn't until, I believe, 2011, I think, I may be misspeaking here, that they were required to use female-bodied crash test dummies when they were testing cars. So what ended up happening was that women were 60% more likely to be seriously injured in a car accident because even in an offline system, there wasn't representation in the way that they were building and testing sort of that product. So this is something that's been going on for years. You can go back and find an example of this in Kodak, where it wasn't until the 1990s that the models that they used to test the coloring in the film included African Americans. So what ended up happening is, and it only happened because chocolate makers and furniture makers came out and said, hey, we don't like the way our stuff is showing up on your screen, that Kodak actually started to look at its chemical composition and change it. So I think we have a long-standing bias of not building products, period, that are inclusive of people that always end up underperforming for one group over another. So the difference is no different with a technical system, but the impact is much wider because these systems can reach millions, tens of millions, hundreds of millions of people much more instantly. So agree that it is a policy issue, but also really want to emphasize that this is something that humans are pretty just bad at in general. And this is something that all of you in this room, whether you plan on becoming an engineer, working at a tech company, working at an NGO, just using your skill set in society, just being a responsible citizen, need to start thinking about when these technologies become adopted at a larger scale by either government entities, by private companies that have reach across different groups or massive reach, that these are things that you should be asking for your policymakers to make decisions about, because when companies themselves make those decisions, they're not always the best candidates to make decisions about what's best for all of society. That's kind of why we have policymakers in the first place. So again, it's not a challenge that's unique to machine learning, but the implications of that is that we can harm people at scale much faster.
Anyone have anything else? So looking on kind of the flip side of this, maybe on a more positive note, a researcher at UBC recently found that applying algorithmic evaluations to home prices helped mitigate overpayment for Black home buyers. So how, if at all, can algorithms be built that help reduce the impact of human biases in areas such as home buying, criminal justice, or anywhere else? Anyone in the
I think there's huge potential. I mean, this is one of the reasons why we use algorithms in the first place. There's lots of capriciousness in human decision making. This is why I like to compare algorithms with the alternative, and which is humans. And so, at least in the criminal justice system, we have the ultimate black box of judges making decisions that they don't have to necessarily justify, or they might give some post hoc rationalization of why they're making decisions. And so certainly, I don't think algorithms are the answer, but I do think that we have to sort of acknowledge the extent to which it's my phone. I do think there are lots of examples where algorithms are improving and reducing human bias in various high-stakes contexts.
I guess this kind of also relates to back when I did banking fraud for behavioral analytics. I mean, there's definitely clusters of individuals that behave differently. Like there's like elderly fraud, which is like a certain type of scam. And so if you knew like what is the age of the user, you can better predict this person is more at risk of being harmed, and so that your model could actually work better if it's targeted towards that particular user. At Apple too, well, we have like this privacy issue where we don't actually have data of this one particular user, so we can't necessarily predict what they're going to do next. It's kind of like aggregated, just this is their good ID for this 15-minute period, and then it changes the next 15 minutes. So there's like no way to like backtrack who it is. And like in some ways we could do better at like giving you what you want, but then there's this constraint of like privacy where we're just not going to go there too. So a balance there.
I don't think I can see that.
And just Ms. Ayede, I don't know what you're allowed to disclose potentially, but
So I think taking a flip side out of just algorithms that make decisions about like binary classifications, like should this person go to jail, should they get a loan, looking at the use cases of ML that actually empower people to experience the world differently. So at Google, there are two apps that come to mind that we've produced. One is called Bolo, and it uses natural language processing to take kids in India who are learning how to read and they can read into the app, and then in real time it gives them coaching. So it helps them learn how to read better by speaking into this application and sort of coaching them into becoming better readers, whether or not they have access to the best-in-class school system or things like that. Another app that comes to mind is one called Lookout. So imagine someone has recently become vision impaired and they struggle with understanding how to navigate a space. The Lookout app allows you to drop your Android phone across your neck, and then it will read what's in the room to you. We have another app, I can't remember the name of it, sorry, that also for folks who are hearing impaired, that will take conversations that are happening in any one of the languages that is supported by Google Translate, and it will transcribe them in real time. So folks who are hearing impaired are able to literally read the conversations going on around them, whether or not they have access to that language, or even if they're like great lip readers. So thinking about the AI, it tends to be like a catch-22. We have these horrible examples of it, like demonstrably harming people, and then we have these examples of how it can magnify and increase the quality of life for so many people. And so again, that responsibility on where that line is falls on a combination of the folks who build the technology and on a combination of the societies in which they're built. So making sure that you all become responsible citizens and ask for the right regulations to make sure that it doesn't sway one way versus the other.
To change directions here a little bit, one challenge that's often cited in addressing bias in machine learning is that the models are often so complicated, they aren't fully designed by even the engineers who build them. So what special considerations, if any, need to be made when addressing a problem that's so complex in nature? And anyone? Mr. Trent.
Sometimes you have to make a trade-off where, as an AI researcher, if transparency matters, you have to choose a model that is more transparent, maybe less accurate, but more explainable. So deep nets notoriously are opaque. Even the people building them don't understand why they make the decisions they do. People are working on this, but at this point that's the case. There was a Microsoft research study years ago in the 90s where they went into a hospital and they wanted to predict, they wanted to help doctors decide what to do with pneumonia patients. So if a person comes into the hospital with pneumonia, if they're not at high risk, they can be sent home. And home rest is the best thing for that. But if they are at high risk, then they should be checked into the hospital immediately. It's very dangerous. So they, this Microsoft team trained a bunch of different models. One of them was a deep net model, and it had the highest accuracy by far on their test data. But then they looked into it a little bit, and they also had a model that they had used, which was a decision tree. And a decision tree gives you some explainability, so you understand why it's making the decisions it's making. With a decision tree, they could see that their deep net model had learned that patients who have asthma should be sent home. And the reason is the data reflected exactly this fact, that asthma sufferers get better care in the hospital. Their outcomes are actually better than the general population. But the machine learning, the deep net model, not understanding anything about this context, took away from this that asthma patients do better when they have asthma, therefore they can go home. So these researchers actually deployed the decision tree model because they weren't sure what other things the deep net model might have picked up. And you just have to be clear about transparency is paramount, that we have to be transparent about the decisions we're making. And if we're creating opaque models, we have to understand that they're being used, they can only be used in contexts where it doesn't matter, until we can understand them better.
Yeah, I guess in terms of building the models, oftentimes you start off doing some sort of decision tree type stuff to make sure that, the data you have is okay, the output's insane, and then maybe you go towards some sort of deep net. But oftentimes that, the deep net happens offline, and at runtime for the ranking, it's always going to be some sort of like a decision tree type model, just because the deep nets, when it goes wrong, it kind of goes really wrong, whereas in terms of the decision trees, they don't really go wrong as much in terms of the ranking. So there is some sort of combination that you can do for the algorithms to optimize things a bit better.
So I think this goes back to a point that Kyle brought up earlier, which is the area of explainability or transparency in machine learning models is brand spanking new, right? So I know last year Google released some research with OpenAI for convolutional neural networks to help you understand like how CNN was learning the difference between a frying pan and a wok, and it's like this visualization tool. That's all great, but that still doesn't explain every type of neural network. And so the question is, with this technology being so new, should we even be using it to solve those complex problems? Is this with something that we don't understand fully, with something that we don't have the ability to explain? Should we be adopting it for some more of these complex issues and complex problems, given the fact that we don't have the ability to go in and explain them, given the fact that we don't have the ability to go in and figure out why they're making the decisions they're making or what associations that they're learning? And that's not a question for tech companies to answer. That's a question for every single person in this room to answer, and to put pressure on different folks who make decisions around how tech companies are allowed to, whether they be policymakers, whether they be NGOs who sort of act as thought leaders in this space, to make sure that we are using it in the way that it can be used while minimizing the amount of harm that it's used for, given the actual state of machine learning. This is not like, so we haven't solved it yet, it's just machine learning is a brand new field in terms of the way it's being commercialized, even though AI has been around for 60, 70 years. And so these are some of the hard questions we have to ask ourselves is, are we maybe moving forward a little too fast with some of these technologies given the current state?
I just want to say I really like this example that Kyle gave. I think it highlights the kind of, error with the often repeated statement that there's a trade-off between accuracy and transparency. And so this example shows that, in fact, you're improving accuracy and transparency at the exact same time because you're applying it in a setting which is not purely predictive based on historical data, but you're using this to intervene on new decisions. And so that's one of the reasons that we're developing a lot of interpretable ML methods in my group. And one of the reasons we do this is because we are using these to inform decisions going forward. And so we have some kind of mental model of what a causal intervention looks like, which isn't purely correlational from the data. This is very tricky, and so there's, it's not like a kind of hard and fast rule of this is going to do what we think it's going to do, but often when we look at it, we do have reason to believe that actually the kind of interpretable, transparent model will perform better in the world if it's deployed rather than the complex model that happens to be predicting better on the training data.
On this topic of transparency, the rise of machine learning in a box type operations, such as Microsoft Azure's Machine Learning Studio, now enables non-engineers to create machine learning models of their own. What, if anything, is the impact of this increasing democratization, accessibility, and prevalence of machine learning in the world?
So at Google, it's not called ML Studio, it's called Auto ML, or Auto Machine Learning. And some of the beauty of it is that we've built Auto ML to be able to allow folks who are non-technical to bring their data to any one of these systems and then be able to train a model, a machine learning model. The awesome part about that, at least from our cloud platform's perspective, is we also simultaneously released a tool called Expendable Ad, which in it builds in other open source research tools. It builds upon a lot of research we've done in explainability, and it has the ability to tell you which feature in your data set contributes most to the outcome of your model. So we didn't just say, hey, here's a tool, go build things. We said, hey, here's a tool. When you build it, here's also a tool that can tell you and explain what it is and what it does. So one of our earliest adopters of AutoML were researchers out of the National Health Services, the NHS in the UK. And so they built a model to be able to detect something called diabetic retinopathy. So if you have diabetes, you become at risk for blindness, right? Based on how far and progressed your condition is. And so when you go to rural areas, diagnosing this condition can take months because it's like you gotta ship out, you have to take the images, you have to physically ship them to someone who can see them, and then that person has to review them, make a decision, and then ship the results back. So we ended up partnering with the government of India to be able to actually test this out in different rural areas to say like, hey, how does this actually, like if instead of sending it off to a ophthalmologist who's like really far away and really overloaded, if we could just hire a bunch of ophthalmologists to tag our training data, be able to build this thing, and then make it so that on the ground or near instantaneously, we could be able to say yes or no, this person has this condition, and how bad the condition is so that they could start treatment, which is what we were able to do. And so we were able to do it. NHS is working on it with an AutoML model, which enables these research scientists with deep domain expertise who are like eye experts, don't touch computers except to send emails, to be able to automate some of their knowledge to be able to scale it, it can be very valuable. But again, I think we took a very responsible, no pun intended, a responsible approach to the way that we developed it, because we also released a series of explainability tools for that. We also limit what you can do inside of each of those. So like if you're doing Vision API, you like can't build like a mass surveillance system. We like inherently limited the platform to prevent some of those things from being built on it.
I think a recurrent theme that's come up this evening a lot is that we are deploying technology before we know how well it works. And there's a real risk of people bringing their data to an online tool from Microsoft or Google or whoever, and assuming that it's working correctly, or that it produces the results that they're looking for. So the interpretability is a big help, and that's great that Google does that, but I think that people need to analyze the outcomes that they're actually seeing from this, and have some way to evaluate whether it's working correctly or not. And introspection of models is helpful, but I think that the measure of the real world impact is what matters, and we as a society are not holding people accountable to do that.
Anyone else like to add? All right. So moving on and kind of turning the tables to look at some potential solutions here, the risks that are often associated with machine learning are not necessarily similar to those that have been dealt by the US justice system in the past. So with that, what changes or new developments, if any, would be necessary in the US justice system to ensure fairness in terms of machine learning? And go ahead if you like.
So in the justice system specifically, probably Sherrod is the best one to answer this.
I'm happy to. But
Just the one thought I wanted to throw out there is that currently we have zero regulation around the use of AI. So there are some jurisdictions that have banned face recognition and some specific uses of AI for a specific purpose. But the general idea of you can use AI to make decisions about human beings, there is no regulation in the US about that. It's starting up in Europe. But let me pass it on to Sherrod to talk about the judicial context.
So I think the simplest thing that we should do in the justice system is ensure transparency in auditing. I think that's more or less a no-brainer. And auditing doesn't necessarily mean that transparency doesn't necessarily mean you just put your code up on GitHub and then let the world do whatever it's going to do. I mean, there are all sorts of problems with that. I mean, in some ways it's too easy and also too hard. But I do think like making sure that there's real access to the models, to the data, to researchers who potentially have signed NDAs or potentially have kind of other privacy constraints in place. A lot of these are sensitive algorithms, sensitive data. But I think that taking that seriously, that any time a government agency, even if it's not in criminal justice, but like broadly government agencies start deploying these types of tools, that there is a mechanism for regularly auditing these systems. I think that's like more or less an easy thing to do, at least from a regulation standpoint. But I want to go back to what I started with and say that I don't think the issues of fairness are fundamentally algorithmic, even in contexts where algorithms are being used to aid decisions. I think we really have to take seriously that, especially in the criminal justice system, that lots and lots of things are broken, and an algorithm is not going to fix it, and an algorithm is also not going to be the thing that fundamentally breaks it. And so a lot of these are what we do with the results of the algorithm. I can have the exact same algorithm producing the exact same recommendations, the exact same predictions, but what I do with those predictions can be good or bad. And so focusing on the algorithm itself, I think is a bit of a red herring. And so I think this is where a lot of the attention is, like how do we regulate algorithms? I would really like to say, have this conversation shift to how do we regulate decisions and ensure that the decisions themselves are much more equitable, especially in the justice system.
Now, as a final question before we move on to Q&A from the audience, I'd like to kind of talk about that thought that accuracy isn't necessarily the same thing as fairness. So machine learning models, for instance, have been implemented in prison systems to determine recidivism scores for inmates. But how, if at all, are researchers responsible for balancing the hunt for statistical truth with the ethical implications of the results? And anyone likes to start?
I've done lots of talking. I have thoughts, but I won't also pass it on.
We have time for everyone else.
Yeah, so I'm thinking about, the balancing the data set, and that's really up to, as an engineer, I would think, okay, what is my distribution of, inmates that exist, the distribution of, the population at large, the differences of, what the outcome is. And so, as an engineer, I guess I would be the one balancing the data set, which I guess with no oversight, at least the small companies that I've been in, to produce some outcome, and you see what is your accuracy, also what is your false positive, false negatives as well, because oftentimes, if your data set is very skewed one way, you might have like a very good accuracy, but you're predicting all the the bigger data set, and you're not really getting kind of like the meat of it. So you also have to deal with skewing the data set as well.
So if you can't, accuracy is a minimum if we're going to achieve some notion of fairness. But there is no 100% accurate AI, and I doubt that there will be. So we've got some percentage of cases that will just be wrong. We know that. So if it's 20%, that's bad. Peck made the point earlier, if it's 1%, but that 1% represents millions of people, that's probably not acceptable regardless. Again, we have to look at what is the real world impact of this technology, and the level of accuracy in this context for this real world impact is part of the decision. And if it's a small number of people, and we know that some 1%, and that represents a small number, are going to be harmed in some way, versus 99% who are going to get some great benefit from that, then that's one of those fairness discussions that society has to have. But I could say that typically it's the vulnerable people who are the 1% who are harmed by this, and we should be rethinking that and making sure that not only looking at the number of people, but which people are in that 1%, and how does it affect them.
Humans are not separate from the technologies we create, whether we're building crash test dummies, or whether we're building recidivism prediction algorithms, or whether we're going to build a robot that can bring me my sodas on campus. Shout out to the Cal alum who did that. And so we have to stop and just remember that technology is not value neutral. It's embedded with the values of the people who create it and the context in which it's used, right? So who that ethical implication falls on are the people who create it, the context in which it's created, and the context in which it's used and deployed. We've been talking a lot about regulation. Yes, the EU is kicking off really heavy-handed regulation, meaning that they're very, very specific in what they want. But the US is also in the early phases of recommending regulation as well. And so you can go and read, I believe if you look up like US AI regulation proposal, something like that, in your Google browser, in your Google Chrome browser, you'll be able to actually find the white paper where the DoD has put out recommendations for how they think both the defense and the population at large should regulate artificial intelligence. So these conversations are happening right now, whether they're happening in like my team meetings at work, or whether they're happening outside as a part of a larger conversation on how we move forward as a society, knowing that these are key elements of it, right? So I think the ethical implications are on all of us. Like if we don't say anything and then the regulation isn't suffice, whose fault is that, right? So I think all of us have a collective responsibility to make sure that the way technology is used and deployed in society, again, whether it's a crash test dummy or an algorithm that's going to predict, what I want to purchase off of an online shopping platform, it's all of our responsibility to make sure that it's deployed in environments that are conducive to the collective whole.
We gotta give Safari here a chance to.
Well, Safari also sometimes goes out to Google.
Teamwork makes the dream work.
Yes.
Do you have anything to add?
No, I guess I spoke there before, so yeah.
All right, so thank you so much, all of you, for your answers today. Now, you go ahead if you want. So we'll now be moving into the audience question and answer portion of this event. I'd like to give everyone in the audience the chance to ask any questions they may have. That being said, please just raise your hand or signal if you would like to ask a question. I'll call on you, and you can go ahead and ask our speakers anything you'd like. Just please remember to keep your questions short and concise if possible. Anyone have any questions?
So there's a lot of newer companies now, like Forward is an example that comes to mind, that are using ML AI to solve practical things like healthcare. Do you all think there should be some kind of governing body, organization that makes sure that their algorithms are fair and treating, I guess, people equally? Or how's the best way to like make sure that all this plethora of new startups coming up are doing the right thing?
Well, I guess I know, just to start off, you know, the Apple Health, right, with like the watch, when you had the EKG, they, you know, were conscientious of making sure they had like various distribution across the population. You know, whether that was regulated externally or internally, I'm not sure, but, you know, and whether FDA approval needed to know, you know, what that distribution was, not sure. But, you know, those were things that probably, you know, should be in consideration.
I think government absolutely has a role in providing some regulation. That right now we have this free market with a very asymmetrical relationship with the technology, where the technology providers know something about the technology. The people who are making decisions about buying it usually don't know much. There is a blind faith among people that this technology just works. We're seeing Google having automatic cars that are driving down the road without drivers. Of course, they have safety drivers with them still, but computers that are winning at complicated games like Go, like, it seems to be amazing, but we're not talking at all about the limitations and the problems with it. I don't know, maybe people are just too dubious, but I think government has a role here.
So I think part of it is, over time, I trust that there will be some type of regulation entity that pops up, just like for the Department of Transportation that overlooks safety metrics, or in healthcare you have different entities that do things like govern for HIPAA, or like in the security space you have folks that govern in different countries for like GDPR, right? And so I think we're just very, very new. So we've talked a lot about what fairness looks like, right? And how there are all these different metrics. Well, Google, we open sourced a tool called Fairness Indicators, which allows you to check your machine learning model while it's in production across, like, I think 12 different fairness metrics. So everything from false positive, false negative, accuracy, recall, precision, AUC, like all these different metrics, but that was just December. So how can we have a regulating body come out when we're just now starting to, even on a technical level, figure out how to analyze these things? So I think, again, it kind of circles back to that conversation of, before we regulate it, how are we even identifying if it's ready to be used in certain contexts? And I think it's a balance of both of those. And then also, a lot of large tech companies have taken the lead, whether it's Microsoft, Google, Facebook, Amazon, Apple, at establishing their own ethical AI charters. So given their industry, given their uses, given how people use their technologies, are building their own sort of self-governing processes in the absence of regulation, which is, in my opinion, a very bright step in the right direction, right? That these companies are even willing to come out publicly and say, this is what we believe in. I know at Google, one of our first red lines is that we won't develop weapons. Some of you guys may be familiar with Project Maven, which was where we were building robots for the DoD. Google employees were very angry, and now we make sure that none of our AI technologies can be used or weaponized, whether they're internal or external. So like, a lot of this stuff is steps in the right direction, but until this industry catches up with other highly regulated industries, where these type of failures happen. So think about healthcare. If a doctor makes a wrong decision, that can cost someone their life. And so how do you plan for that failure modality? What happens if a doctor makes a wrong decision about a medication? Or let's say a mechanic on a plane forgets to fix a part and it causes the whole plane to crash. We have regulated industries that deal with this type of stuff, but they also provide consistent frameworks across these different companies to be able to document like what is being built, what might happen if that thing malfunctions, and sort of how we collectively deal with the consequences of that. And I think we're just not mature enough there yet in machine learning, but I do think that we're heading in the right direction, and in the next year or two, you'll definitely see a lot more AI regulation around the world that will shape how some of these companies take an approach outside of self-regulating.
So, other questions?
Thank you all for coming. Machine learning models have been implemented in predictive policing as well as in prison systems to determine recidivism scores, for instance. How, if at all, are researchers responsible for balancing statistical truth with the ethical implications of their results?
Sure. I think it's really good question, something that, I think it's a really good question, something I've personally struggled with quite a bit. I don't think there's any easy answer to this. I mean, my worry is that, ultimately in the criminal justice system, we don't care just about outcomes tomorrow or in a year. We really care about outcomes, a generation from now. And I do think there's a lot of evidence that short-term outcomes can be improved by using these types of predictive algorithms. For example, one study that we did in a major city suggests that using algorithms to guide human decision-making could reduce incarceration, pretrial incarceration rates by 30%. So that's, quite a big improvement. At the same time, we don't know what the equilibrium effects of this is going to be. And so, worst cases, it's something like mandatory minimums where, in some sense, this is trying to make the justice system more equitable, but it also has all these downstream consequences that ultimately might lead to more incarceration down the road. So I think it's super hard, and it really is something that I personally, I've like lost sleep over, of saying we're building this thing, and I'm pretty sure it is going to improve things in the short term, but is that closing the door to other advances or other ways of thinking about decarceration that now, someone's going to say, oh, don't worry about this anymore because we have this algorithm and this is better than we had before, when really we should say the entire system is so broken that we just have to like tear everything down and rebuild it. And I just don't know what the answer is. I think this is something that people individually have to make decisions about, and I guess kind of the decisions that I make, you can see by my behavior, is that it's, I do think that there's a role of algorithms in the justice system. I do think these short-term benefits outweigh the long-term potential costs. But I don't know for sure, and I'm like totally respectful of people who say, I don't want to work in this because it's too much. It's like they think and they have a just different prior on how these things are going to play out. So I think it's exactly the right question to ask. I think everybody who's working in this field should ask themselves what they think is going to happen and not be naive about the potential downstream consequences of the work that they're doing. But at the end, I don't know. I don't know what the answer is.
I would just repeat what Sherrod said in a different way, or a different way of thinking about it, is that an AI researcher, I think the easy answer is yes, you have a responsibility to think about the impact of the work you do. I mean, that's true of anybody. But it's not easy, and I think that's what he's getting at, is that these can be hard questions. So for example, in the predictive policing question, I think that in doing that, we're just recapitulating historic racism. That the data is just tainted because that's our history. But there are others who are working in that field that think they're actually reducing crime. So if I'm wrong and they're right, then they're doing a good thing. But if they believe they're right, then they have done that introspection and decided I'm doing the right thing because I'm reducing crime. It's not an easy question.
One thing that I've definitely gained from this, first of all, thank you all so much for coming, and thank you to the Berkeley Forum for putting on this event. It's really great. One thing that I've kind of gained from this talk is that there is no standard definition of fairness, but there's also been a call for, regulation and governance of this. But given the fact that there are so many different definitions of fairness that exist from country to country, how would you all recommend forming an international or global framework if necessary to govern, this practice?
Just quickly, I would say that AI is, if not already, pervasive in everything, and there's not going to be one body that says, okay, we are responsible for AI. It's all of these different regulatory bodies we already have need to be thinking about how AI fits into their picture, and there may be additional regulatory bodies we need. I don't think there's one overriding AI body that can be responsible for that.
Yeah, also when I think of all the companies out there, small and large, it'd be hard to regulate every single one of them. And so also some of it is, well, the people who actually buy the products, if they notice that there is some bias, maybe they might not want to use it. So it's also kind of a combination of who the user is too, I think.
There's actually a research paper out there that highlights 21 different definitions of fairness that was produced for ACM. Has a conference called FATSTAR, which is fairness, accountability, and transparency in machine learning. So if you're interested in checking out some of the cutting edge research, you should definitely go check out some of the papers that were just published in the proceedings that happened in January. But in that paper, it literally highlights there is no universal definition of fairness. And so to echo the points here, I think that each individual societal, geographic, cultural context has to come up with their own sort of regulation. I think that part of what is happening is that there are different types of risk assessments that are being developed either by companies, by just researchers in this field, by governmental bodies that are looking at how do we even, if we take the word fairness out of it and we just don't want unjust impact from one group to another, if that's the definition we're going for, how do we even analyze that that's what's going to happen? And so looking at things like, I know in the human rights field, there's like a UN human rights impact assessment. How does that translate over into machine learning? So there are researchers either individually at these companies looking at those questions, also within individual regulatory bodies. So like, what is fair in war? Where fairness does not mean that the enemy gets a fair chance, right? Which is something the DoD actually explicitly said when they built their own AI principles, is like, we don't believe it's fair if the enemy has the same opportunity to like combat us as us, because war is inherently unfair. And so I think part of it is one, taking a look at what regulations are out there, two, looking at the different human rights groups that are trying to build some of these assessment frameworks, and three, understanding what you believe is right in the context of how AI is being used in the different societal contexts that you exist in, and then pushing those regulatory bodies to reflect that in the legislation and the assessments that they do put out, right? So I think we all can kind of agree we like HIPAA, that we like the fact that like people aren't just sitting there like sending out our health data to each other, that there is some regulation that has that. And then also to echo the point about it not being universal, in Europe they have something, it's a, I don't remember the name of it, but it's a consumer protection law. So like if a product that you purchase is default or like doesn't work by default, you can sue the company. And so now they're like, what does that mean for machine learning models? They may be underperformed. Should they be able to sue the like, creators of the machine learning models? And so these are questions that are actively being discussed right now on an international stage. And I think it's definitely would encourage you to join that dialogue.
If there are no other questions, then I'd like to welcome our president, Charlie McMurray, back up to the stage.
Let's get Let's get a round of applause for our moderator, Noah. So if you've never been to a Berkeley Forum event before, welcome. Hope you had a great first time. A tradition of Berkeley Forum events is we have framed copies of these posters that we designed for all of our speakers, and I will award them now. So here you go. You all will have your name framed in a beautiful poster. Thank you. Cool. So we have a great lineup of events coming up this semester. In fact, we're going to be having an event on affirmative action this Thursday. I encourage you all to check out our Facebook page at facebook.com/Berkeley Forum to stay up to date on all of our Facebook events. And yeah, thanks so much for coming out tonight. We're going to put a URL on the board for feedback if you would like to share your thoughts on what you thought about this event. But yeah, thanks for coming out tonight.